engineer and anything like that would have gone through this before. This is like a bit of a refresher. Current and voltage in series circuits, current and voltage in parallel circuits, and current and voltage in combination circuits. Yep. So, first of all, general symbol, and there are others that get used, but for a DC voltage source, circle with a continuous line above a dashed line, right? E is textbooks, but try and use E to be a source voltage, like a battery or a generator. Yeah, and then there's a V drops across components as we go around the circuit. The arrow points towards the positive terminal and indicates the direction of the current. So here, if we put our wires on here, this would be the positive terminal, and in a closed circuit, current would flow, conventional current would flow that way. So with sources, the current arrows go in the direction of the arrow, the voltage arrow indicating the positive terminal. Please don't let me see you put arrows across components with arrowheads on both ends. That very specifically to indicate the polarity of voltage drop. Alright? And well, we do Kirchhoff's laws, which we're kind of touching on this week, but we're going to formalize it into the actual laws first. When we have a resistance circuit, okay, we can put a voltage arrow to show there's a drop across it. In that direction. So the volt drop arrows go in the opposite direction, flow through the component. So I have Alright, so, and that this will become, like I say, important when we start to look at circuit complex in nature. We're going to be wanting to make sure we look at the diagram and put in the right direction so that we end up with the right answer. Alright, we do Kirchhoff's law calculations. So, series voltage divider. Voltage divider, what we've got is source voltage here, so that must be the positive terminal, that the negative of that source. Arrow pointing towards the positive terminal. Taking a current, go in the direction shown by the arrow there, okay, and actually we could call it IT there for I total, because in a series circuit be one current. Yep. For the current, we must remember is this terminal ways along the way. But eventually, it must all meet up again somewhere. It all comes back to that terminal. Yeah. We end up with 2 volt drops. These go, as you notice, against the direction of current flowing left to right. Voltage arrows go right to left. Yeah. From RT is R1 plus R2. Yeah. We over RT. Actually, look. It is well prepared. Cool. Multiplied, and therefore we can substitute that in if we can calculate. Okay, one of the consistent mistakes is to say for a student, my question. If you had, again, if we had the current here be half an amp, 10 to the 20. Yeah. Student. I'm more about that, like, yeah, when we get the combination circuits, mistake commonly making. But, you know, and so you have to be aware of things that can easily happen, and then you prepare for them. All right. So, example problem: resistors of value 20 ohms. At 120 ohms within 6 pi of 100 volts. Calculate the current flowing. So we see the end and put an arrow on that way. Volts for E. That means a current flows that way. We've been asked to find which direction do I put the voltage arrows for the volt drops across the three resistors. That way. And we'll call them V1, V2 and V3. Okay, well, we're going to start then. Yeah. So RT, 1, 2, plus R3, plus R3, 215 ohms. Yep. Form. E over RT. Numbers in, calculate. 0.47 or 470 milliamps. That's easy to say. That's perhaps easier to use in another calculation. Get the rest of them. Right. We found the current flow, and that was what was asked for. V1 1 resistor times nine point 3 on my note. Yeah, leaf. .4. So if we add them up, along for the fact that we rounded the current calculator, which is Kirchhoff's voltage law, but we ain't formalised. Yeah. So where if you get one complete loop in a circuit, we'll follow up a bit more formally next time with Kirchhoff's voltage law, but that's the essence of it. Okay. On the next page, what you'll see in some textbooks is a talk about the voltage. You can do some calculation all in one go. No rule. And then separate here. 1 times R1. But then, if we substitute into the equation, that equation, number 2, that's for I, so instead of writing I, write E. So, what we can find the voltage V1 in one go by is equal to E1 times the resistor we're interested in divided by the 2 resistors. And you wouldn't have, is that, sorry? Because then this equation would be three resistors, you're far better. And V2, you just substitute R2 for R1, look. Yeah? So you can go straight to that voltage with one. That way, I would be happy to do an exam use a voltage divider or because then you that's not as a two. Right. In what is understanding the underlying electrical principles. What was the voltage V1? Just quickly. 94 and V2 35.3 56.4. The voltage divided in proportion to resistor values, the biggest voltage across the resistor. And that's the underlying principle worth remembering in a series circuit, because then it'll check, does that look right? Small resistors got but one's about we're not in a math session here, so if you underline that'll remember how to do these. Check that look. Voltage divider is to give an output voltage V2 of 18 volts from an input voltage 45 volts is equal to 50. The R1. What's the relevant voltage divider rule? We're not being given a current here. voltage divider rule, we can do one. We could look at the voltage drop, but what could we do? The voltage divider rule. If this is V2, isn't it? We'll call that V1. Yeah. You can say V2 equals E R2 over R1 plus R2. Now we've got to get R1 on its own. Bear in mind that that implies brackets there. What could we do? No, because if you what you've effectively got there is ER2 over R1 plus ER2 over R2. So you can't do what you're suggesting. Yeah. You could do what you're saying is divide both sides by what? You'd end up with V2 share. What is ER2 divided by ER2? 1. So what you have is 1 plus R1 plus R2. Still do it that way. But why not? Instead of doing that, remember we want to find R1. So why do substitute on the? This is all about is rearranging formulas. It's not about the ability to be able to move things. It's about what to do. We multiply by R2. That's V2 R1 plus R2 equals E times 2. V2 R1 is equal to E R2. Without taking. Divide by R1 plus R2, the E R2, 2. Now, subtract 2. So R to E over 2 minus R2. Yeah, now we can put our numbers in. The value of resistor we want is E, which was 45 volts, times R2, 50 ohms, divided by V2, 18 volts, minus the value of R2, 50 ohms. .75 ohms. Yeah. Okay, so that's how you could possibly use the voltage divider rule to solve such a problem in that you could do that quite. In series, away